In this lecture, we are going to look at examples of combinations of functions. f of x and g of x are given. F of x equals to 1 over x and g of x equals to square root of x plus 1. We want to describe the domain of each of the combinations, and we will find an expression for the combination function. Let's start with finding the domain of f and g. What's the domain of f? Function f of x is 1 over x, and we can never have 0 in the denominator. So the restriction on x is that x cannot be 0. Or in interval notation, domain of f would be from negative infinity to 0 exclusive union from 0 to infinity. How about the domain of g? Function g has a square root, and we know that what's inside the square root has to be positive. So we need x plus 1 is greater than or equals to 0, which means x has to be greater than or equals to negative 1. So using the interval notation, domain of g will be from negative 1 inclusive to positive infinity. Now let's find the domain of each of the combination functions. In part A, we have 3f. So the input to this function will be inside the f function. So the domain of 3f will be the same as domain of f. So it is also when x does not equal to 0. How about its expression? When we have a scalar in front, we simply multiply the scalar to the function. So we have 3 times f of x, which is 1 over x. So 3f is 3 over x. In part B, we have f plus g. So the input will be inside the f function and the g function. So the domain of this function has to be the intersection of the domains of f and g. Domain of f is when x does not equal to 0, and domain of g is when x is greater than negative 1. So the domain of this would be x is greater than negative 1 but exclude 0. So using the interval notation, domain of f plus g equals from negative 1 to 0 exclusive and then union from 0 to infinity. In the expression of this function, we simply add out the two functions. So this equals 1 over x plus square root of x plus 1. How about part C, f divided by g? Here we put the input into f and the g function, so the domain will also be intersection of domains of f and g. Furthermore, here we have the function g of x in the denominator, and we cannot have a 0 denominator. So another restriction is that the input we put into g of x has to give us an output that is non-zero. So domain of f divided by g, first constraint is x has to be inside the domain of f and g, which is from negative 1 to 0, union 0 to infinity. The second constraint is that we need g of x does not equal to 0. G of x is square root of x plus 1. This does not equal to 0 means x cannot be negative 1. So we combine this. We get that the domain of f divided by g has to be exclusive of negative 1 to 0, union from 0 to infinity. And what's its expression? So we put the function f in the numerator, which is 1 over x, and in the denominator we have square root of x plus 1. Let's rewrite that as 1 divided by x times square root of x plus 1. Note that we can also see its domain from this form. So from this form, we have 1 over x times the square root of x plus 1. Since we cannot have a 0 denominator, so x cannot be 0. Furthermore, x plus 1 cannot be 0. So x cannot be 0 or negative 1. And we have the square root, which means what's inside the square root has to be positive. So x plus 1 has to be positive. So x has to be greater than negative 1. And in part D, we have f of g, or we can write that as f of g of x. So the x serves as input for the function g. So x has to be inside the domain of g. Furthermore, g of x serves as input for function f. So the range of g has to be inside the domain of f. So first of all, x has to be inside domain of g. Domain of g is when x is greater than negative 1. So from negative 1 inclusive to infinity. And the second constraint is that we need the value of g of x is inside the domain of f. So we need g of x is inside domain of f. Domain of f is when x does not equal to 0, and the value of g of x is square root of x plus 1. So we need square root of x plus 1 does not equal to 0. And we get x cannot be negative 1. Then we combine these two again. We get that the domain of f of g would be from negative 1 exclusive to infinity. And what would be its expression? So we have f of function g of x is square root of x plus 1. And function f is 1 over the input. So we get 1 over square root of x plus 1. Note that we can also see the domain from this expression. We have square root of x plus 1 in the denominator. Since the denominator cannot be 0, so x cannot be negative 1. And what's inside the square root has to be positive, so we also need x is greater than negative 1. So from this expression, we can also see the domain of this function should be from negative 1 to infinity. And the last example is g of f. We can rewrite g dot f as g of f of x. So now we put the x into the f function. So the domain of this function has to be within domain of f. Furthermore, f of x now serves as the input for g of x. So the values for f of x has to be inside the domain of g of x. So to find its domain of g dot f, we have two constraints. First one, it has to be inside domain of f, which is x does not equal to 0. And the second constraint is we need the value from f of x be within domain of g. Domain of g is when x is greater than or equals to negative 1. And the value of f of x is 1 over x. So we need this belongs to from negative 1 to infinity. Or I can rewrite this as negative 1 is smaller than or equals to the function 1 over x, which is smaller than or equals to infinity. The later part is always true. Any real number is always smaller than the infinity, so we only need to focus on this part. This part says x has to be smaller than or equals to negative 1, or when x is greater than or equals to 0. Now let's combine these two constraints. We get x cannot be 0, and x has to be smaller than or equals to negative 1, or greater than or equals to 0. So we get the domain of g of f. That would be from negative infinity to negative 1 inclusive union from 0 exclusive to infinity. And what would be the expression of this function? So we put f of x as input into g of x. F of x is 1 over x. And function g is square root of the input plus 1. And the input here is 1 over x. So g dot f is square root of 1 over x plus 1. And that's the end of the lecture. In the next lecture, we'll look at example of transformations of functions.